In this video, we are going to talk about a model called Zero Intelligence Trading. So first of all, where does this model come from? First, who built it? This model was originally developed by Mark E. McBride from Department of Economics, Miami University. The latest update was January 2nd, 2014. And we can find an introductory video and the code from this website. However, the model we are watching now is the model updated and further explored, modified, and heavily commented by me. Okay, and this model can also be downloaded from this site. So, what is zero intelligence trading? The idea and the model actually come from a paper published in 1993 by Gould and Sutton. The paper title is Allocative Efficiency Markets with Zero Intelligence Traders. Markets as a partial substitute for individual rationality. And here is the abstract of this paper, which have a brilliant summary, very brief, clear summary of what this model is trying to do. It says, we report market experiments in which human traders are replaced by zero intelligence programs that submit random bids and offers imposing budget constraints. In other words, not permitting traders to sell below their cost or to buy above their values is sufficient to raise the allocative efficiency of these auctions close to 100%. Allocative efficiency of a double auction derives largely from its structure, independent of traders' motivation, intelligence, or learning. So it's very clear. This model, this ABM model we are watching now, is a model trying to replicate the market experiments right here, which will replace human traders. We are not considering human traders in this model. The agents are not human traders. The agents are supposedly to be the zero intelligence programs. And those programs, those zero intelligence agents are going to submit random bids and offers. And as a result, meanwhile, there is a budget constraint. That is, the sellers will not sell their products below the cost. The buyers will not buy the products above their valuations. So keep that constraint kept. The whole model will achieve the allocative efficiency very close to 100%, which means the market's efficiency, the market's equilibrium is actually achieved. So this is the goal of this model. Okay, so let's just very briefly to have a look whether this model achieved this goal. First of all, we set up the model. We have two lines. These two lines is the blue one is demand curve, the red one is supply curve. The cross points is the price of the equilibrium price, which balance the demand and supply. And the purple line are actually the price of each trade. Okay, it is not well, it is the ideal trading price because every trading price right here is actually the average price between seller's cost and the buyer's valuation. So there are two prices right here, and then we'll find the middle price right here. Why is the middle price? Because the natural explanation is that the buyer, although has the value to be its maximum price to offer, but he would like to bargain. He wanted to buy with a cheaper, lower price. Also, seller always want to sell above the cost. So when they bargain, the outcome would be the middle price, the average price. That is reasonable. So we say all the idealized trading results, the transaction price would be the average price. So we would assume all the trades, the price is somewhere in the middle between the valuation and the cost. And it turns out that all the prices seems in the same line. Okay, so this is the ideal situation about the supply and the demand price equilibrium. So how do our agent do? If the agent is zero intelligence, they just randomly bid and ask, and they only need to keep one constraint, that is the buyer's offer will not beyond its valuation, the seller's price offer will not below its cost. Keep that constraint. How would our model do? Let's have a look. Well, it turns out that the black line right here are the agent's trading price. So it's very rigid. It's a very volatile. The price quite different. But if we sum the data up, we will see that there are totally 30 trades achieved by our zero intelligent agents. And the average price of all these 30 trades is 102, which is very, very close to the idealized equilibrium price, which is 104. Although the standard deviation, the variation is big. But the market efficiency, according to the calculation, is nearly 100. It's 92%. The perfect situation is 100%. So at this point, we can say, well, this model actually successfully replicated the model proposed by the paper and gets the result, which is what the paper concluded. So from this point of view, we say this model achieved the goal it's trying to achieve, okay? But that is not all we want to explore. We want to explore a little bit further. The reason why I'm interested in this model is because I watched a video in which Axtell, the Professor Axtell, talk about agent-based modeling, and there seems to be a possibility that all economic concepts and formulas can be taught differently and explored in more experimental and realistic or even lively way through agent-based modeling. And it used this zero intelligence trading model to make an example to show that, well, agent-based modeling can be a different approach towards economics. So I look into this paper and trying to study this model and make it to have a look how exactly a model was built and how economic concepts like the supply and demand curve, the price equilibrium, can be reproduced through an agent model like this one. Okay, so we will explore a little bit more than just get the outcome like this one. Okay, so how do we explore more? First of all, we need to understand how do these three lines come from? How do we really understand the setup situation? Because, I mean, so far we say the model proves the points made by the paper, but does it really? Can we verify it? Does everything says what it really intends to do? Does it do what the paper says? So to do that, to prove that, to verify that, we need to at least understand what's the setup really set up for us, and what does Go really do for us. Okay. So what are these three lines exactly tells us, and what does this mean? So first of all, there's something to be cautious about. That is, the x-axis is not quantity of commodities. They are just the number of price offers, or the number of they're just the number of prices offers. They are not even the number of trades or deals. Okay, this is something we need to be aware of, because originally the label is quantity. People may consider quantity to be the commodity quantity because it's demand and supply. So shouldn't it be okay? As the price going down, the quantity going up. As the price going up, the quantity going up. So actually, the quantity is not the quantity of commodity. This quantity is just the price offers. Okay, the number of price offers. Okay, and then all the buy valuation of prices and the seller's cost prices are known and laid out in order. So what we see here, the blue line, the red line, the blue line is about the demand, is from the buyer. So these are the buyers' valuation. For the commodity they want to buy, they give them different price for the value of that commodity. So different traders have different value price for the same property. So it's ranging from almost $0 to $100. And the red line is about the seller's perspective, the producer's perspective. For the same products they make, they have different cost, ranging from 0 to about 200. Okay, so these two lines, they stand for different things. And also, they are forming the line because the price are ranging from high to low for the buyer, and from low to high for the seller. Why ranging this way? Ranging the prices this way. Why they shouldn't be scattered points, but connecting lines from small to high, from large to small. Why is that? That's because we, in the ideal situation, allow the buyers and the sellers to know all their options at once. For the buyers, they know all the prices of the sellers. They also know the other valuation prices from the other buyers. So all the prices are known to every single traders in the markets. Okay, so this only happens in an idealized situation. Therefore, all the prices are ranked. Okay, ranked like this. And for the buyers, every buyer knows the other buyer's price. Every buyer knows every seller's price. So for the buyer who are willing to offer higher price, it gives the buyer priorities. It gives the buyer privileges to talk to the seller with the lowest selling price. Because I mean, I have a lot more money. I can buy things with higher price, so everybody will listen to me. Every seller would like to sell it to me. So the higher price buyer can talk to the lowest price seller or any other sellers as long as he wants to deal with them. However, for low price buyer, the price is not so attractive, so maybe nobody wants to listen to them or to deal with them. And for the high price seller, no buyers would like to directly to buy from them because they're just too expensive. So we put them together in the same horizontal line. And for this, buyers and sellers, they have more privileges, so they put together. So they were more likely to trade and to deal. And these people, they probably, well, naturally they can't deal because they only offer very low price and they produce at a very high price. These people are not privileged. Although they put together, but unlikely they will have a deal. Okay, this is why we draw lines like this. So as we can see, all the all the idealized transaction price is also happening here. No price, no deal price happen from here because they can't trade. Because for them to trade, it's just making no sense. They will lose money, they will lose money as well. So here we have deals, but when they make a deal, since they all know the price, this buyer wouldn't to buy things at their valuation price because he knows there are many sellers offer much lower price. And for the seller, they wouldn't agree to sell their stuff at their cost because they know many buyers would offer higher price. So they will bargain and the price will be reached in the middle because the middle seems very fair, okay, idealized. So these transaction prices are idealized but reasonable. They are middle price. And it seems that all the price is about 100 or near 100. So these are the process how the three lines are constructed. It seems reasonable. It's an idealized world, but every analysis seems reasonable. Okay, and that is supposed to be taught in the economics books, I suppose. And okay, that's fine. That's good. But more importantly is our model. So far we just laid out what the textbook says, the mainstream economic textbook says about demand and supply and price equilibrium. But what about the intelligence, zero intelligence model? How would those agents trade? How would their price appear? And were those kind of situation, where those kind of zero intelligence traders and their trading would achieve a market efficiency? By the way, the market efficiency, according to this model, is based on the market surplus. Surplus means that the seller sell their goods to the buyer with the price of the valuation. So for example, this seller, they want to sell it at their cost is 13.2, and the buyer are willing to offer 189 to buy. So there is a big margin right here. There's a big profit can be made right here, and then we accumulate the profits of all these trades and add those profits together, and those profits is market surpluses. Okay, and the market efficiency is that considering the zero agents, the zero intelligent agents, they will trade, and they may not trade exactly right here. They may trade at different places. So every trade, their surplus, their profits is different. But if all their trades surplus or profits added together is very close to the idealized market surplus, then the ratio would be 1. Okay. If the zero intelligent agents, their trade profits is very small compared to the idealized market surplus. If they only achieve maybe 30 or 20 or 40, which means the market efficiency, the market is not very efficient. Or those zero intelligent agents, when they trade, they can't reach the market efficient situation. Okay, so we use this market efficiency to test, to verify whether our zero intelligence agents, when they do the simple trading, can they also reach market efficient situation or not? Right. So when we go, it appears it does very close to 100%. So it is efficient, even though there are lots of variations in a way, but the average price is not very far away from the idealized price equilibrium. Okay, so in the next video, we are going to examine more of how these lines come about, and also what are this green line and what are this purple line.